Let's learn about the diagonals of quadrilaterals here. Quadrilaterals being four-sided figures, each quadrilateral has two diagonals. A square has two diagonals, a rhombus has two diagonals. Now we are going to look at these diagonals and find out whether they are equal in length. Are they equal in length? And number two, do they bisect each other? Bisecting means cutting each other into two equal halves. Do they do that? And whether they are perpendicular. So first let's start with a square. A square being a perfect quadrilateral. I think this would be the best one to start with. A perfect quadrilateral in the sense all sides are equal in a square and each angle, there are four angles and each angle is equal to 90 degrees. So let us explore a square first. How do we conclude whether these diagonals are equal or they bisect each other? The tool which we are going to use here is the congruency of triangles. Triangle congruency can be looked up here if you are not aware of it. We have a playlist covering the congruency of triangles. I would just like to brief you about it. Suppose you have two triangles. They are perfectly congruent or they can be superimposed on one another if all the three angles and all the three sides are exactly equal. But arriving at whether all the three angles or all the three sides are equal, it's enough if you prove that any of the three angles or sides, if any three equalities are proved, that is two angles in one side or three sides or one angle and two sides, if any of them is equal, then we can safely conclude that the triangles are congruent. So let us use this now and arrive at whether the diagonals are equal. So the first triangle which I am going to consider for equality, for proving the equality of diagonals, is what I am highlighting. We need the full diagonal. So let's take this brown triangle as one and the other one including the other diagonal as a side. So this white as another. So now let's compare the brown and the white triangles and see if the diagonals are equal. As I said, we'll have to check if any of these three sides or angles are equal. So the one which strikes me first is this side. It's common to both the triangles, and these two sides, the sides of a square being equal in length, these two sides are equal also. And now of course the third side is what we have to arrive at. So we have an angle, yes, an angle here. This is also 90. This angle of the brown triangle is 90 degree and this angle of the white triangle is also 90 degrees. So by SAS congruency criteria, side angle side congruency criteria, we can say that these two diagonals are equal. Okay, why do we say that? Because if the triangles are congruent, then we can say that each one of those corresponding sides and each one of those corresponding angles are equal. So this diagonal, the one which is in brown here, and the other one white are equal to one another. So are the diagonals equal? Yes. Now to find out whether they bisect each other, let me erase everything, because in order to see whether they bisect each other, we need to consider two other triangles which has half the diagonals. So let me take this brown triangle and this one opposite to it, white. So what do we have to infer now? Whether these two sides are equal and whether these two are equal in length, right? This is what we are planning to find out now. So off to comparing the triangles. Now what strikes me first is that, yeah, the sides are equal in length. So these two sides, the sides of a square, so these two sides are equal. And can we say anything about angles? Because obviously the other two sides we cannot say anything. So I think because the sides of a square, the opposite sides are parallel. Let me just highlight it. So this side is parallel to this side. So this becomes a transversal, right? This is a transversal. So we can conclude that these two angles are alternate interior angles and they are equal in length. Now suppose we consider the other triangle as the transversal. These two angles are equal in length. So now we have three things which are equal, two angles and one side which is the included side. So by ASA congruency criteria, we can say that these two triangles are congruent. So what has resulted now proving the congruency? The sides, each one of the sides of these triangles are equal in length if they are congruent to one another by corresponding parts of congruent triangles. So this side, this length, the half the diagonal is equal to the other half. That is, the diagonals cut each other into equal halves. These two are equal. So the question whether they bisect each other, yes. They do bisect each other. As I had written yes here also, I erased it. And now, are they perpendicular to one another? So we have concluded that yes, they bisect each other. Now let's find out whether they are perpendicular to one another. Now which of the two triangles do you think we have to compare for finding out the angles if they are equal? So if the diagonal, if you can say that this diagonal being a linear pair, the angle here is 180 degrees, right? If we can conclude that these two angles are equal in length, equal in degrees. If the two angles are equal, then the 180 degrees would be divided equally, so 90 degree each, and we would have arrived at our result. So now I think you would have got a clue as to the two triangles which we should be considering. It should be the two adjacent triangles. Let me erase this white line here. Yeah. Two adjacent triangles. So let me highlight the adjacent triangles. Let this be one white and the other one green. So we have a full diagonal to ourselves here. And we also just now proved that the diagonals are cut into equal halves. So these two are equal. And this is of course common. This is the common to both the triangles. And since sides of the square are already equal in length, we have these two are equal. So by SSS congruency criteria, the two triangles are congruent to one another. The three sides are equal to one another, three corresponding sides. So the triangles are congruent. So what have we concluded? The two angles here are equal. And if I say that the white angle here plus the white angle there is 180 degrees, and we know that they are equal, so two whites is equal to 180 degrees. So what is the each white angle? It is 180 by 2, 90 degrees. So now we have the answer to the question, are they perpendicular? Yes, they are perpendicular. So in the case of a square, we have proved that they are equal in length, they bisect each other, and they are perpendicular. Now we are going to do the same drill for each one of these figures. Of course, it would be faster because we have learnt the basics of how to do it. So let's do it in our upcoming video.